Hey, so this is a video that I'm hoping to make that you can use to help you study for the final. This is the same review that we had in class, but the idea is that I'll have this here. I'm also going to be working at the same time in this document, which is what I would recommend using as your notes. So if you did not have this down on a separate piece of paper for your notes, you can start writing it now. This is what I would write, but I'll at the same time, like you might want more, you might want less. I'll let you decide. Okay, so we are going to start on this review. We did this in class. If you were not here physically or mentally, I'm just going to go over it again. So the big thing right here is number one. If we had picked one marble out of the bag, what we need to look for, if it says without replacing, that's a really good hint that it's going to be dependent. And dependent, what dependent means is that the first one will affect the other one, will affect the second one, right? Because you would keep it out. It's going to change the possibility of what you're going to get on the next one. So it was going to be dependent, right? But then this says will not, and we don't want will not. We want it will affect it. So it will affect it. Then for the next one. Okay, so we have Joey's sock drawer is unorganized and contains all those socks. We want to know what is the probability that Joey chooses a sock at random that is, and this is what you're wanting to look for, brown or a dress sock, right? So what we're going to want to have for this one is we're going to do, we want the number of brown or black, because it can be either one, divided by the total, right? So I'm gonna, and then, so brown or black. So we have brown, and black, right? So it's gonna be 7 plus 6 plus 2, which would be 15, right? Divided by the total, which would be 7 plus 6 plus 6 plus 2, which is 21. And then if you remember in Desmos, let me see if I can find the Desmos app. I do, good. So on Desmos, as a reminder of what you can do, is if you needed to simplify that fraction and you didn't know how, this is what you could do. So you could do 15 divided by 21, and then this little button that's on the left side, remember that circle? Push that circle button and it'll change it, except for it's supposed to be 21, JK, 21. It will be the 5/7, right? Okay, so, all right, so it's gonna be this one because we did that. So this one will be D, this one will be B, and what I would put on my notes then is I would go like this. The probability of or something like A or B would be the number of A plus the number of B, like the specific thing, right, that they were saying. So like that's where we said, this one was where we said it was brown and a dress sock, right? Divided by the total number. And then it's going to be a fraction. So we got 15 out of 21. And then I used Desmos to help me. And we got 5 out of 7. Okay. So that was a plus right there. Plus we added them. Okay, then the next one. Suppose, I had to look this up. So suppose P and Q are independent events. So what we do is the probability of Q and R is equal to the probability of Q multiplied by the probability of R. So our Q was 0.99, our R was 0.34, and if we multiply those, we would get this one. Another way of thinking of this is about 1, a little bit less than 1, And if I did 1 times by 0.34, I want a little less than that, and the only one that's a little less than that is C. So the answer for this, C. Like how it randomly changed. Okay. So then this is a frequency table. So we're looking at frequency table. Oh, let me see. What would I put on my notes? On my notes, I would put the probability of A. And B would be the probability of A multiplied by the probability of B. And then I'm going to put use Desmos if needed. They are so loud. I'm so sorry that they're so loud. I hope you can hear this still. I'm so sorry. Okay, then let's see. Then we're going to come to the next one. So a frequency table, if it says a frequency table, we want to find the probability that the first day is humanities given male. So we want the number of males in humanities, or humanities and male, but males in humanities, divided by the number of males. So we have 85, and then the total number of males, if we just added these up, that would be 235. So 85 divided by 235, and we do this in Desmos, and that would give us 0.3617, which would round to D. So if it says given, that's what I'm looking for in my notes. Oh, wrong thing. Okay, if it says given, then it would be like the specific, the number of the specific divided by the given, the number given. So like that's where we said given males. And up here, that's where we said the males in humanities. And then we used Desmos again to simplify that. They're so noisy. Okay. It's the best I can do. Sorry. And then right here, this one I would recommend to graph in Desmos. So you're going to go into Desmos and you're going to type in negative x squared plus 36. And I can see that the two places that they cross are 6 and negative 6 and positive 6. So negative 6, positive 6. And I can tell the number up here would be 36, right? So I'm going to draw that on my paper. But these are the x-intercepts, the 6 and negative 6, and the top one is the y-intercept, right? So we'll go, I'll draw this. So draw this, there's negative 6, there's positive 6, and it went up to 36. So the only one that has the y-intercept at 36 and 6 and negative 6 would be B. Right, this one can't be it because, anyway, so it's B. So I'm going to put x and y-intercepts, just as a reminder on my notes. X and y-intercepts. Graph in Desmos. And then I'll draw that little picture. X-intercepts. And this one up here. Y-intercept. Okay. Then, all right. Then this one. So this is showing we have this 4 multiplied by the f of x. This means multiply all f of x values by negative 4. So if I did negative 8 times by negative 4 and all of these times by negative 4 and keep on going down, I would get positive 32, negative 12, and you'll notice only one of them has those two, so I can stop. And I know that the answer would be A. So this, I'm just going to say for the sake of notes, this is a vertical stretch of 4, and the negative means it's going to reflect over the x-axis. Okay, so coming back to the notes, I would put, if it was negative 4 f of x in the table, means you're going to multiply the f of x column by negative 4. That's really all you need there. I mean, that's all I would need. Okay, write an equation for this. Then so the factor. So this is what you need to know for this. If it says factor, that means multiply. This is probably really big. I mean small. If it says factor, that means multiply. So we're going to multiply by 1/2. So the answer would have to be D. So what I would put on my notes is, if it says factor, a factor means multiply. So we're just going to leave it like that. Okay. Then, next one. What is the graph of this one? And it's showing up 2 units. So if it says up 2 units, it really needs to go up 2 units. But this one's tricky because you'll notice that these grid lines, like this one and this one, those grid lines, they go by 2s. So I'm going to put grid lines go by 2s. So if we were down here at -1 and we went up 2 units, we're going to be at +1. So it's going to be like that. And the only one that matches that graph is A. So that's the main thing that I would need to remember, is it just goes up 2 and then beware the grid lines. So we would say up 2. It goes up 2 units. Beware the grid lines. I'm going to put by 2s because maybe it goes by 2s. Maybe it does, maybe it doesn't. I don't know on the test. I don't remember. Okay, and then this is f of x equals -3x, and so vertically stretched by a factor. Hey, look, there's the word factor. It means multiply.
See you later.
See ya. And then reflected, if it says reflected, it means it's going to be opposite. So right now we have our 3x, -3x. The factor would mean we multiply it by 7, and then the opposite means we're just going to make it the 7 negative. So if we multiply those, we'd get positive 21x. So the answer for this one has to be B. So things I would want is like factor means multiply, reflected means opposite, and then you literally multiply, right? Here's the multiply by 7, and then negative means, opposite means just like opposite of whatever it was. It was negative, so it would make it positive. So I'm going to put here, I keep on going back to the wrong one. So we would have factor, multiply, reflected, opposite sign. So I'm going to put an example on here. So I did 3x by a factor of 7 and reflected. Means it would be -7 times by 3x. -3x would equal positive 21x. Okay. Then This function is f of x equals x squared. So good, look at the squared, made it on there. Okay, so if we're going left 9 units, that means we're gonna add 9, and up 7 also means we're gonna add 7. So I'm gonna put this little note on here. Left means add, but if it goes right, I should put to the x. Right means subtract from the x, and then this up or down just means add or subtract, right? It's pretty basic. So that one would be plus 9 and plus 7 leaves us with C. And then on my notes, I would put something like left means add to x, right means subtract from x, then up means just add, down means subtract. So we did left 9, up 7 would be x plus 9 squared plus 7. Okay, that's all I think I would need. Okay, so this one I'm going to put it into Desmos, and you might have to use some other other things that you need to do in order to use that to graph it. So let me show you in the app. So I don't have on my computer the absolute, I don't have on my iPad the absolute value thing, but notice if I click that bar, then do you see like above the ABC thing, there's the absolute value? So that's what you can use. So 2x, was it minus 24? Yeah. And then there's the rest of that. Okay. So, and I don't need that one on, or that one. But see how it kind of like bounces off of 12, right? So I'm going to draw this on my notes here. On my paper. It went like this and basically like bounced off of 12. So look at all these parts. See, those all look exactly the same. So that's not going to help us if we look at that. So, but if this has 12, chances are it has to do with 12, right? So the answer would be A. And it does. So I'm going to go like this. And right here, so absolute value, graphing absolute values. So I'm going to go, if I did absolute value of 2x minus 24, looked like off of 12. So look for this number, because that's what will help you. Okay. And then 12. Again, I'm going to put this, I'm going to put two different functions. I'm going to do x squared, negative x squared plus 16. And then I'm also going to do negative x squared plus 16 is greater than 0. Because if we see those two, it will help us. So I'm going to do that in Desmos. Desmos. So going into Desmos. And I'm going to delete all, then it sets everything back. So we have negative x squared plus 24. No, what is it? Negative x squared plus 16. Plus 16. And then the other one is negative x squared plus 16. And we want to know when is it greater than 0. So when I graph that, I did both of them because then you can see like it's kind of weird right here. But there's the negative 4 and the 4. And then it's we're interested only in the top part of that because that's where the graph works, right? So we'll come back here. And that's going to be the frowny face, right? It's going to be one of those two. And then the only one that means in between, if you look at this option versus this option, this is the one that means in between. Because literally, the x is between -4 and 4. So that would be, it would have dashed lines there, and it would be shaded in between, like we had, right? So what I would put on my notes for this is, I would put graph negative x squared plus 16 and negative x squared plus 16 is greater than 0. And then I can see that it would be like between -4 and +4. And so then it would be -4 is less than x is less than 4. And I'm going to put here that that was between. Okay, wait, wrong thing. Okay. All right. There's a lot of going back and forth, huh? Okay, what are the solutions of this system? So this is where I would just type it into Desmos and graph it. And if we graph it, we have 2x minus y equals 9. So I'm going to clear it out. Delete all. Okay. 2x minus y equals 9. And the other one was 4x minus 2y equals 18. Bye. Okay, so look at this thing. I don't know if you saw it. Like if I turn that graph on and off, see they're both the same exact line. So that leads to some really good notes. So first of all, since they're the same line, they're always crossing. And always crossing means infinitely many solutions. So B. Oh, did I put the answer up here? I didn't put B right there. Okay. So then this is what I would put on my notes. I'm just going to put it right on the notes. I'm going to put, for systems, graph in Desmos. And if they're the same line, sorry again, means infinitely, oh, I should put infinitely if they're the same line, which it was, it means infinitely many solutions. If they're parallel lines, means they're never going to cross, so no solution. And if they cross, that equals a point, which means one solution. Okay. Whole page, front page of notes, and we're halfway through. This is good. Right? We're halfway through? Yeah, good. Okay. Number 14. So this is what we did not do the other day. I have no idea what the time signature is for where we're at, but we're basically going to do the same thing. So we're going to jump right into it. What we're doing is we're going to graph this into Desmos. I don't even think I'm going to make separate notes, but you are going to have to remember that. So -0.7, -0.4, and 1.6. Gosh. Okay. So delete all. So -0.7 x minus 0.4 y equals 1.6. Is that what it is? 1.6. Gonna double check. Yeah. Did I get 0.4 y? Yeah, I did. Okay. They had a 0 in front of those, but it's the same thing. 0. 0. Okay. And then 0.4, 0.1, and -1.9. 0.4. So 0.4x minus 0.1y equals negative, was it 1.9? Or was it 0.9? 1.9, nice. Okay, so I can see that they cross at the point negative 4, 3. So I want to pick the one that looks about like this with negative 4, 3 as the answer. So it looks like it's C. See if anything else matches that. Ooh. What is the difference between C and D? Oh. Negative 4, 3. Oh, here it is. Negative 4, 3. It's D. So not this one. Whew. It's a good thing we checked, right? So, because this had the wrong point, so that's wrong. And so the answer was negative 4, 3, D. Whoa. Okay, so back on our notes that we've been making, what I would put for the notes is, I'm going to do this one up here, because it's the same. But I'm going to do with systems, make sure the point matches. So in Desmos, where those crossed, see how I have negative 4, 3 for the point? You want to make sure it matches the negative 4, 3 when you're graphing it. Okay, I think that's all we needed right there. Let's do the next one. Sorry about the noise. I am in esports. They're just being noisy. Okay, use the vertex form to write the equation of the parabola. Okay, so this is how I would write the equation of the parabola. I can see that that point right there is negative 3, 3. So if I had the vertex negative 3, 3, when I put that into the parabola, it's going to be x plus 3. Remember how it's opposite, squared, and then plus 3. And then there's probably a number in front of it, because it looks like these two are the same, almost the same, right? So then I want to check, is it going to be the negative or is it not going to be the negative? Well, I can see because this is frowny face, like it's a frown, then it's got to be this one. Frowny means negative in the front. Okay, so it'd have to be A. In my notes, I'm going to put notes about that. So I would put writing in vertex form. So if I had the point, the vertex, so like we did this, we found the vertex. Find the point of the vertex. Step 2, plug it in. Remember, the x is opposite. And then I'll put, oops, frowny face graphs mean negative is in front. So I'm going to do that example because I like that example. If I had the point negative 3, 3, then this is going to be x plus 3 squared, and then plus 3 right here. And then it was frowny, and then the negative in front. We didn't really care about the number. You could always go back and double check with Desmos to see if it works. If it doesn't work, right? And that's okay. Okay, then what are the vertex and axis of symmetry of this equation? So if it asked for what is the vertex and axis of symmetry, I would for sure graph it in Desmos. You can do it another way, but why, right? So negative 2x squared plus 16x minus 14. Delete all. So negative 2x squared. Oh man, I forgot it already. Plus 16x. X minus 14. Yeah, okay, good. And if I do that, I can grab this, and there's the vertex is at that negative 418. So I'm going to just try this out. So 418 would be parentheses. I'd have parentheses x, and then the opposite of 4 would be minus 4, and then square it, and then plus 18. So they're not quite the same. See, like they're reflected, so something needs to change with this. And remember, we talked about frowny faces, so I could put a negative in the front. And see how it's not quite skinny enough, so I could add a 2 in there, and voila, there it is. So see how I did that all? I graphed it to find the vertex, plugged the vertex in, and then kind of messed with the number in the front till I got it. So, oh yeah, all we needed was we didn't have to have all that stuff. Cool. So the vertex was 418, and that was correct, right? So it's either going to be this one or this one. But then the axis of symmetry is the same thing that the x is. So it has to be this one, because they have to be the same. So that answer would be D. Did I put A up here? I did. That answer would be D. And then let's go and put in our notes. So if we have finding the vertex and axis of symmetry, so like negative 2x squared plus 16x minus 14. So step 1, graph it and click on the vertex. So we found that it was 418. And then the next thing that we need to know is the axis of symmetry is x equals 4. Like it's that same number, right? They have to match. Okay, so that's all we had to have for that. I made it more complicated when I described it with the graph, but we're okay. We survived, right? Let's come back to the problems. Okay, so now we want the maximum or minimum. Again, we're going to graph in Desmos. The max and the min is going to be the highest or the lowest. And then the range is going to be either up or down from there. So 2x plus 4x minus 20, 2x squared. So, 2x squared plus 4x, and then it was minus 20. 20, let's double check. Minus 20, yep. We wanted Desmos. It's right there. I should have reset the okay. So it's gonna, I can see that's a maximum, and the maximum value is the negative 18, and then it goes down from there. So maximum has down from there. A minimum would have a minimum, and then up from there, right? So when I graphed in Desmos, I found the vertex was it 22? What was it? I think something's wrong. Oh, it's because it's not a negative. Psych. Is 2x. Ah, okay, that makes more sense. Okay. So it's not the y-intercept, it's the minimum value. So it's negative 22, and it goes up from there. So that's a minimum at negative 22, and it goes up from there. So we graphed it, looked at so we graphed it so that it was a minimum. So minimum, 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 minimum. They all said minimum. And then we see that these two have minimum at 22. That's good. So it can't be those because that's not 22. But then we want these two numbers should match. So the answer is C. So let's go to our notes. Again, we can pause this. You can pause this and then make it work better for you. My Apple Pencil's low. So find the vertex of axis of symmetry, find minimum, max, and the range. So 1, graph it, and click on vertex. The max or the min is equal to the y value. If it's a maximum, then it'd be y is less than the max. If it's a minimum, y would be greater than the min. And it just depends, like, so this would be a max would be like a frowny face graph, the y value, right? And then this would be right there. But these have to match.
Yep, I'm targeting you, bro. You know what? Counter would be great against this guy.
Okay. Let's do some more.
I keep getting hit by Marlo because I'm getting hard targeted by Marlo.
Keep on going back. Okay, so see that? There was the minimum, and everything is going to be bigger than that. So the range would be greater than that. Hopefully the sound is okay. Probably horrible, but what can I do? Okay. What is the expression in factored form? So I'm going to talk about 2 different ways of doing this. So this is one way. We're going to look at this number and think of all the possible things that you could multiply to get 36. To help you do that, you could use the multiplication table on your table. And I'm going to finish doing it this way. Actually, when I'm looking at these numbers, I can see that I have 9 and 4, so I can see for sure that they want to have 9 and 4. So we want numbers that multiply to get to this number that add up to this number. Well, the only ones that are going to add up to that number, they both have to be negatives, so it'd have to be B. Another way of doing it that we did in class is we graphed it, but we had to remember opposites. You have to remember the opposites. They're so noisy. Especially when they're sitting right next to each other, it cracks me up. Okay. So x squared. Was it minus 13x? And then plus 36. So we look at the y-intercepts for the x-intercepts for these, and they need to be the opposites of those. So that's why we get the minus 4 and the minus 9. So, yeah. Or graph, and then they're opposites of the x-intercepts. Yeah, and I need to go back into our notes now to make notes on this.
All right. Okay.
Okay. Find the factored form. This is the way that we talked about in class, is we graph it. Graph it. Step 2, the x-intercepts, make them go opposite in the parentheses. So when we graphed it, we found out we had the points 4, 0, and 9, 0. And then that meant that we had, actually, I'm going to move that over. And then this meant that we had x minus 4, and the plus 9 meant we had x minus 9. That's the way that we did it most commonly in class, and might be the easiest way for you to remember it. on the test. So I'm just going to write it like that. If you want to know the other way, we can do that more, but we didn't do it as much in class, so I'm not going to do it. Okay, and then which expression is equivalent to that one? So it looks like, first of all, these 19s stayed there. So I'm going to assume it's one of those. And then, let's see, does that simplify to be that? Let's just check. So we want to see, what will this factor into being? But then here's the tricky thing, is there's this negative right there is going to make it a little bit different. Yeah, so let's just graph it. Negative x squared minus 4x plus 55. So negative x squared minus 4x plus 55. And then we get, see ya. Oop. So something must have been wrong.
Why would you do this to me, bro?
Equals 19. Okay, see ya. Equals 19. Bye. You too. Oof. Those are weird. So what did I do wrong? X squared minus 4x plus 55 equals 19. Okay, this is going to take some other moves. I'm going to do a different video.